Imagine an era so early in the universe that even light itself seemed hesitant to make its appearance. A time when emptiness reigned supreme, when the fundamental forces of nature had just started to carve out the blueprint of existence. Now, picture the Webb Telescope, humanity's most advanced eye in the sky, peering into this primordial age, and finding not the bustling emergence of stars and galaxies, but emptiness. Nothingness stretching as far as it can see. Einstein predicted this, not in an exact sense but in a way that few understood until now. And what Webb has found, it's not just about the absence of matter, it's a revelation that confirms one of the most astonishing insights Einstein ever had. When Einstein put forth his general theory of relativity, he didn't just describe gravity, he reimagined the universe itself. Space and time weren't static, they were dynamic, flexible, capable of bending, stretching, even rippling like the surface of a pond. But what was even more mind-bending? Einstein imagined the cosmos as a place that, initially, may not have been brimming with matter at all. Fast forward to the James Webb Space Telescope, the most powerful tool we've ever had to look back in time. Webb has now observed some of the deepest corners of the universe, regions so far away that they reveal what our universe looked like mere hundreds of millions of years after the Big Bang. And what did it find? Emptiness. No galaxies, no stars, just a void. Exactly as Einstein's equations might have suggested, a universe waiting, preparing itself for something extraordinary. Why? And how could Einstein, nearly 100 years ago, have envisioned such a moment? Today we're diving deep into the latest discoveries made by the James Webb Space Telescope, how they align with Einstein's predictions, and what this all means for our understanding of the universe. But to do that, we need to first travel back to where it all began. The Big Bang, the moment that gave birth to everything. Imagine that, in a single blinding instant, a universe smaller than an atom expanded into the vast complex cosmos we see today. But here's where things get interesting. Despite that initial explosion of energy, the very early universe wasn't a place filled with stars or even light. It was, for the most part, dark and empty. For the first few 100 million years, the universe was more like a blank canvas, an ocean of darkness waiting for the first sparks of creation. And this is what the James Webb Space Telescope confirmed, an era of true cosmic emptiness, before the formation of the first galaxies. But let's rewind to Einstein. Back in the early 20th century, when he proposed his general theory of relativity, Einstein thought something wasn't quite right. The equations he had developed hinted at a dynamic universe, one that wasn't static. This was confusing because back then, most scientists believed that the universe was eternal and unchanging. In an effort to align his equations with this belief, Einstein added a fudge factor, something he called the cosmological constant, to force his model into being static. The irony? The cosmological constant was one of his biggest regrets, but as it turns out, he was more correct than he even realized. When scientists discovered that the universe was actually expanding, Einstein abandoned the constant, reportedly calling it his greatest blunder. But recent observations suggest that there was something inherently insightful about that constant, something deeply intertwined with the concept of emptiness itself. Enter the James Webb Telescope. Its mission? To look deeper and further back in time than any other telescope. It was designed to uncover secrets about the early universe, to catch glimpses of the first galaxies, the first stars, and maybe even signs of life. Instead, what it found was exactly what Einstein's math seemed to hint at. Vast stretches of emptiness in the extremely early universe. Let's put this into perspective. Webb is looking at galaxies as they were about 13 billion years ago, just a few 100 million years after the Big Bang. Yet what it found was not a cosmic nursery bustling with new stars and galaxies. It found emptiness, like a paused moment before the universe decided to take its next big step. Almost as if the universe itself had to take a deep breath before exhaling into the form we know today. So, what does this emptiness mean? Why is it so important? For decades, scientists have tried to piece together the timeline of the universe. One of the most perplexing questions was, how did the cosmos evolve from a hot, dense state into the intricate web of galaxies and clusters we observe today? The answer might just lie in this era of emptiness, this dark, cold expanse where gravity began its silent work of pulling together hydrogen atoms, laying the groundwork for future stars and galaxies. Einstein's theory suggested that, left unchecked, gravity would either pull everything into a big crunch or the universe would continue expanding forever. And in this early epoch, gravity was indeed the quiet architect. It shaped the future by taking advantage of the emptiness. Slowly, imperceptibly, hydrogen began to clump together. Gravity began forming the seeds of future galaxies, and it's this very process that Webb has observed traces of. Webb's observations confirm that the early universe wasn't just a chaotic mess of rapid expansion, it was a highly orchestrated ballet of emptiness giving rise to everything. It's the very reason we're here today, because gravity, time, and vast stretches of emptiness collaborated in a delicate dance. But here's a question: why did the universe need this emptiness at all? Why wasn't everything created at once in a fiery explosion, bursting with stars and galaxies? The emptiness served as a necessary interlude, a pause that allowed the forces of nature to settle, to start working slowly but surely. Without this period, the first stars wouldn't have formed, and there wouldn't have been time for the elements necessary for life to be created. Think of it as the soil needing time to prepare before the first seeds could take root. And in a way, Einstein's cosmological constant, the same one he had such mixed feelings about, might explain why the universe has vast periods of stillness before bursts of creation. Recent theories suggest that dark energy, which is linked to Einstein's constant, plays a role in this delicate balance. It's almost poetic. The universe needs both emptiness and energy, a balance of stillness and movement, to create something as beautiful as galaxies, stars, and eventually life itself. Einstein was, in a sense, a man ahead of his time, writing equations that would make sense only after decades of observation. His theories painted a picture of a universe that was constantly changing, evolving, and expanding, something far beyond the comprehension of most of his contemporaries. He saw the universe as an intricate tapestry, where every thread mattered, where even the emptiness served a vital role. His view of a dynamic universe was not just about matter and gravity, it was about the subtle interplay between presence and absence, creation and void. He understood that creation often emerges from nothingness, that the emptiness itself was not void of meaning, but was rather a fundamental building block of existence. This insight allowed Einstein to perceive the universe as a profound dance between what is seen and what is unseen, a constant ebb and flow that shapes everything around us. So what does this mean for us today? Webb's observations of emptiness are not just about understanding where stars come from, they're about comprehending the very nature of existence itself. The emptiness that Webb has captured is a profound reminder that even in the most desolate and dark stretches of the cosmos, there is the potential for incredible beauty and complexity to emerge. Before there were galaxies, before stars illuminated the cosmos, there was darkness, an essential precursor to everything. This darkness was not just the absence of light, it was the fertile ground upon which the universe would build its most intricate structures. The empty voids were the places where gravity began its gentle pull, gathering hydrogen atoms that would one day ignite into brilliant stars. It's a reminder that even in our own lives, the times that seem empty or devoid of progress might actually be laying the groundwork for something extraordinary. Just as the universe used this darkness as a foundation, perhaps our own moments of quiet, our own struggles through seemingly empty times, are the very moments that set the stage for our brightest futures. Think about it. If the universe needed emptiness to create everything we see today, what might that tell us about our own lives? Could it mean that our own periods of stillness, those moments when nothing seems to be happening, are actually filled with unseen potential, about the value of pauses, the importance of the quiet moments that precede creation? Perhaps these pauses are not just empty intervals, but fertile grounds where ideas and possibilities are taking root, waiting for the right conditions to bloom. Just as the universe needed time to gather its resources, perhaps moments of stillness in our lives are not empty at all but rather crucial intervals preparing us for something greater, something yet to be born from within us. Einstein was right after all. The emptiness was never truly empty. It was pregnant with possibilities, a waiting canvas on which the universe would paint its most magnificent creations. It was a period filled with the promise of everything yet to come, a time when the universe was poised to transform the void into a cosmos full of stars, galaxies, and the building blocks of life itself. And it took the James Webb Space Telescope almost 100 years after Einstein's groundbreaking theories to confirm the true beauty and potential of that emptiness. The emptiness was a crucial phase, one that allowed gravity to weave its invisible threads, drawing matter together, slowly giving rise to the galaxies we see today. It was a foundational silence that spoke volumes, setting the stage for a future filled with light and wonder. The universe, in its wisdom, starts with nothing so it can create everything. It begins with emptiness, a void that holds the potential for every star, every galaxy, and every planet that would eventually form. This emptiness is not a failure or an absence, it is a preparation, an intentional stillness that lays the foundation for future growth. A powerful reminder that even the quietest, darkest times have purpose. Just as the universe needed this emptiness to create everything that exists today, we too may need moments of silence, moments where nothing seems to happen, to prepare for the bursts of creativity and growth that lie ahead. And maybe that's the true secret Einstein unlocked, a cosmic truth about beginnings, about how stillness precedes creation, and about how these seemingly empty phases are crucial for the wonders that follow. It's a truth that still resonates today, reminding us that our own periods of uncertainty or stillness might be preparing us for something magnificent yet to come. What do you think? Could the emptiness of space hold more secrets than we can even imagine? Could there be mysteries hidden in that dark void that challenge everything we believe about the nature of existence? And how do Einstein's ideas about the universe challenge the way we see our own lives? Could embracing these vast stretches of emptiness change the way we understand our own potential, the way we look at our own moments of stillness and waiting? Drop your thoughts in the comments below, and let's explore these cosmic mysteries together. Let's ponder the silence of the universe and the profound lessons it might hold for us all.